I'm going to go over these three graphical problems first, just because that way then we can erase the graphs and have more board space to work out this problem here. So this first function, is it even, odd, or neither? It's going to be neither. This point is what makes it neither. This point does not have a mirror image. If this were going to be symmetric about the y-axis, that point would have to have a mirror image over here. And of course, none of these other points have a mirror image across the y-axis. If I didn't have this point here, this would be symmetric about the origin. But this point, if we were symmetric about the origin, it would have to have a mirror image down here, and it doesn't. Probably the easiest thing to do is just take the worksheet, flip it upside down. It looks different, because when you flip it upside down, there's a point here, whereas when it's right side up, there's a point here. So this one is neither. All right, for this, looks like we've got symmetry about the y-axis. So this function would be even. Now, for the third one, my freehand picture here isn't really great. If you actually look on the worksheet, it does look like all of these bumps are the same size and shape. And if you turn that upside down, it looks exactly the same. So this function is an example of one that's odd. Hopefully you recognized that function. Now, I didn't tell you exactly what the x and y values were here, but that looks an awful lot like the sine function. And when we get to reviewing our trig functions, one of the things that we're going to review is the fact that the sine function is an odd function. All right, so those are our graphical examples. Now, I want to take a look at this function f of x here. And it's tempting to say, oh, I've got even powers and odd powers, so it's neither. But things get a little bit more complicated when you've got a fraction. So if I take a look, if I work with f of the opposite of x, I'm replacing every single x with the opposite of x. So on top, we're going to get the opposite of x squared plus 2. On bottom, we're getting the opposite of x cubed minus the opposite of x. And notice, when I'm plugging in the opposite of x, I put that in parentheses. Now in my next step, I'm going to simplify. On top, the opposite of x squared is the same as x squared, because that's an even power. And of course, 2 just stays as 2. On bottom, this becomes the opposite of x cubed, and minus a negative x becomes a plus x. So if I take a look at this fraction, the top of the fraction is exactly the same as the top of the fraction I had here. The bottom of the fraction is exactly the opposite, because now I've got a negative x cubed, but a positive x. So this fraction, the top of it was an even function. The bottom of it, by itself, was an odd function. What does that mean for the fraction? Well, on bottom, if I were to factor out a negative 1, because we just said the bottom that we have here is exactly the opposite of the bottom of the original denominator, this would become x cubed minus x. So here we can see exactly the same top, the opposite of the bottom. But remember, with a fraction, if you have the opposite of a fraction, you can associate that negative sign with one of three things. You can put it with the top, you can put it with the bottom, or you can just bump it to the front and associate it with the entire fraction. So having the same top but the opposite bottom means I'm getting the opposite fraction. So this is giving me the opposite of f of x, and so this function here is odd. So if I'm just adding and subtracting a bunch of powers, if I have a mixture of even and odd powers, I'm going to get something that's neither. But once I throw in division to create a fraction, the picture becomes a little bit more complicated. And in this case, having all even powers on top and all odd powers on bottom meant that I got the same top but the opposite bottom, which gives me the opposite fraction. All right, excellent. And I do want to see your work justified. So even if you've got some shortcuts and you look at something and you're like, I'm pretty sure that's going to be even or odd, get in the habit of writing out, this is what I get when I plug in the opposite input, and simplifying it so that you can justify your answer.